This is section 4.2, day 2, and we are going to talk just a little bit more about all of our trig functions, the unit circle, and how to evaluate the additional 3 trig functions, our reciprocal trig functions today. So just a quick recap, we got some quadrant info here. We've talked about how cosine, sine, and tangent are all positive in this quadrant. All of our coordinates, all of our exact values are positive. In this quadrant, our cosines are negative because we're moving to the left. Remember, cosine's your x. Sine is going to be positive because sine is your y value. That's going up. And tangent is a combination of those two. So a negative and a positive. Whoa, I wrote an x. That's a positive. A negative and a positive make a negative. And in this quadrant, your points go negative, positive. So that's why your cosine's negative, sine's positive. In the third quadrant, cosine is negative, sine is negative as well, which actually makes tangent positive, because when you put two negatives together, we'll get a positive. In this quadrant, we were negative for our points. This quadrant, we've got a cosine positive, sine is negative, and tangent then is negative. And in this quadrant, all of our points went positive, negative. So every trig function has 2 quadrants where it's positive, 2 quadrants where it's negative, and they're not the same. All 3 of these have different places where they are positive and negative. Our reciprocal trig functions, remember reciprocal just means a flipped fraction. These are not inverses. We will get to those yet this chapter, but these are not inverses. These are called reciprocal trig functions. So our sign, just to recap, doing our SOHCAHTOA business, so opposite over hypotenuse is y over r. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sine's reciprocal trig function is called cosecant, and it is just that flipped, so r over y. You could also say hypotenuse over opposite. You're literally just flipping sine over. The next one, cosine's reciprocal, is called secant, and you would then be r over x, also the same as hypotenuse over adjacent, since you are just flipping cosine over. Tangent goes with cotangent. That's the only one that makes sense. And this one would just be that flip, so x over y, and then it would also be adjacent over opposite. So those are just called our reciprocal trig functions. You literally are just flipping the values. So this one says determine the exact values of the 6 trig functions for this point. So what it means is I've got this triangle. I'll give a little, like this is the origin coordinate system. Drawing this triangle. Since those are both positive, I'm going to put it in the first quadrant. I went over 12/13 and I'm going up 5/13. If we do a quick Pythagorean's theorem on that, so 12/13 squared plus 5/13 squared, you will find out that the radius is a 1. So I can do Pythagoras, figure out my third side. In this case, it was my hypotenuse, and now we're just going to list out all of our trig values. Since that is a 1, that means we're in the unit circle. So when I go to do my sine, that is just my y value. So it's just 5/13. It would technically be 5/13 over 1, but we don't need the over 1, so just the y value. Cosine is adjacent over hypotenuse, so 12/13 over 1, but again, I don't need the over 1, so I'll leave that off. And tangent is supposed to be y over x, so I'm going to put 5/13 over 12/13. And now we got to fix this stacked fraction, so I'm going to multiply by 13 over 12, cancel the bottoms, cancel the 13s, and I end up with 5/12. To do my reciprocal trig functions, I'm going to squeeze them in here. I'll kind of like this. Sine goes with cosecant, so I'm going to flip it. Cosine goes with secant. I'm just going to flip it. And tangent goes with cotangent. Just going to flip it. Those are just the reciprocals. Take the function, or take the answer and flip it over. This one says, given that sine is -3/8, can you evaluate all 6 trig functions? So these are the 6 we're talking about, sine, cosine, tan, and then the reciprocal ones. And this one, I'm going to also be able to draw a picture of for a triangle. Sine is supposed to be opposite over hypotenuse, so I'll just do a quick little sketch over here. Since this is, this is a negative. Hold on, I need a little whiteout. I skipped right over that part. So we have to pick out which quadrant we're going to be in if we are negative. So we are either in second quadrant, third quadrant or fourth quadrant. Those are the two places where sine is negative. And I should have probably given you more information to determine which one this is, so let's just agree that this is going to be in quadrant 3. You definitely need one more piece of information that I should have included there. Hopefully I redo this video in the future. But your opposite is 3 and your hypotenuse is 8, and then you decide which one of these has to be negative. So in order for you to travel left, that's definitely going to be negative, and for you to travel down, that will also be negative. The 8 won't be negative. That is a hypotenuse. There's no way you could have a negative hypotenuse, because once you do Pythagorean's theorem on these two, you would square them, and that would cancel out the negative. So your hypotenuse will always be positive, so your 3 happens to be negative. If you go ahead and do Pythagorean's theorem, so negative 3 squared plus, well, x squared or a squared or whatever you want to put there, and then 8 squared, you end up with square root of 55. And will be negative because we're moving to the left. So now I'm going to figure out all 6 of my trig functions. So I've got sine, cos, and tan, and then we'll do the reciprocal ones as well. So the sine is supposed to be opposite over adjacent, and we already had that given, so negative 3/8. Cosine is adjacent, so negative 55 over 8. And then tangent is opposite over adjacent, so negative 3 over negative square root of 55. Can't have a root in the denominator, so we'll fix that. I can plus both of those and then do a square root of 55 on the top and the bottom. So I end up with 3 root 55 over 55. So those two roots kind of cancel each other out. My reciprocal functions then, cosecant is going to be negative 8/3. Secant is going to, theta, is going to be negative 8 over square root of 55. Again, I'm in that I can't have a square root in the bottom, so we'll multiply by square root of 55 to get rid of it. So negative 8 square roots of 55 over 55. And then tangent is going to be this flipped. So here, we're going to do cotangent, tangent to cotangent. Here is just a little trick you can use. If I flip this, I'm going to end up with a root in the denominator. I'm going to have to fix that. If I just go back to the original thing that I had and flip this, I'll actually kind of avoid doing all that work. Remember that cotangent is just adjacent over opposite, so I could just do negative root 55 over negative 3 and then plus those. Just trying to avoid doing extra work by having to fix another root 55 by being in the denominator. So I can look at these as well to help me figure out what my trig functions are. I can just flip the originals. That is a way I can do it as well. Evaluate the exact value. So these values are unit circle values, so I'm grabbing my unit circle to use. First one says we'd like the secant at pi over 2, so I'm going to go to pi over 2. The secant is supposed to be the flip of the cosine. So if I could just figure out what the cosine is, I'll just flip that. So cosine is the x value. Let's go like this. Is 0. Technically that's over a 1. That at least gives you something to flip. So your secant of 1/2, of pi over 2 is 1 over 0, which is undefined. Next up we have cotangent of 3 pi over 2. So looking at 3 pi over 2 right here, we'd like to do the cotangent, which is really just tangent but flipped. So the tangent at 3 pi over 2 would be y over x, so negative 1 over 0. So I'm just going to flip that, 0 over negative 1, which is a 0. Next I've got cosecant of 0. So looking at my 0 degrees angle, my y value for cosecant is 0. So cosecant, remember, is just the flip of sine. So sine is 0. We're going to put that over a 1 just so I can flip it. So this would be 1 over 0, which is undefined. Next up, we've got cosecant at 60. Here's my 60 degrees. Cosecant is just sine. So the sine at 60 is square root of 3 over 2. So we're going to flip that. So it'll be 2 over square root of 3, which we know we can't have. So we'll multiply by square root of 3 to fix that. So 2 square roots of 3 over 3. That is my answer. Secant of 11 pi over 6. Finding 11 pi over 6 right here. Secant goes with cosine, so we're really doing the cosine at 11 pi over 6. Looks like that is square root of 3 over 2. Then we're going to flip this, so it'll be 2 over root 3, and we just did all that exact same work in the last question, so I know that this is going to turn out to be 2 square roots of 3 over 3. Got cotangent of negative 11 pi over 2. I don't have that on my circle, but let's see if we can figure it out. It just means that I'm going to do 11 90s, essentially, in the negative direction. So here's 1 pi over 2, here's 2 pi over 2, and 3 pi over 2, and 4, 5, 6, 7, 8, 9, 10, 11. So that's negative 11 pi over 2, which really just means we're doing the cotangent at pi over 2, which means I need the tangent, which would be 1 over 0, and we're going to flip that. So 0 over 1, and 0 over 1 is just 0. Last two, it says, can you evaluate them without using a calculator? So this first one says the cosecant of theta is square root of 2. So I can turn cosecant into sine. So all I have to do is flip this. So if I flip it into 1 over cosecant, I also have to flip that. And 1 over cosecant is sine, so that's nice. And 1 over square root of 2. Now we can't have square roots in the bottom, so we'll fix that. So I'd end up with square root of 2 over 2. That's on my unit circle. And they're just saying what angles, where does that happen? It happens in 2 places. It happens at 45 degrees, and it happens at 135 degrees. Or you can write pi over 4 and 5 pi over 4. Last one, I've got cotangent equals the square root of 3 over 3. So that goes with tangent, so I'm going to flip this over. And then I can't have roots in the bottom, so let's fix that real quick. And those 3's cancel, so it's kind of nice. So I'm looking at square root of 3. What angles have a tangent of square root of 3? We've put all those tangents in on our circle today. So the angles that have tangents of square root of 3 are your 60s. So that'll be 60 degrees and then 240. So just getting more used to our unit circle, how to solve for all the 6 trig functions when you're given just one.